Hello everybody, thanks for coming today. So before we start, I just would like to make some checks with you because I know some of the people, some other faces seems to be a little bit more new to me. So who already attended a wine science forum or any presentation that Nomacorc put together? Okay, so that's not so many. Okay, so that's probably less than 50%. So that's interesting. So there will be some background information at the beginning so that we put everybody on the same level of understanding why we are here and why we are talking about the topics that we are covering today. Okay, and let's start. So the idea of these meetings that we organize all around the world, they are called a little bit differently. When we are in French, we call this rencontre onologique. I can't even say how it is called in seminari enology probably in Italy or something like this. So we tour the world and we share information that we gathered through our research programs and some practical aspects as well. And so we like to call this from oxygen in wine, from theory to practice, trying to go sometimes a little bit deep in the chemistry, the mechanisms that are involved in oxidation of wines, but at the same time we also want to give practical solutions to the industry. So there's a little bit of mix of these two aspects, okay? And you are going to look at this throughout the presentation. So just as a reminder about Nomacorc, so some of you are using our closures, so you know us. But if you are not using the technology, you need to understand why a closure company embarked so heavily in our oxygen and wine topic. When we produce our closure through the co-extrusion process, we produce sort of a long sausage, long spaghetti that we're going to cut in small pieces. All the closures are very consistent. They are coming from the same long, continuous process. And our closures are made of two components. Okay, you have the center, the core, that is made of a formed polyethylene structure that is based on a cellular structure, allowing oxygen to entering through the foam into the bottle. Okay, and for us, this is really a way to filter somehow the oxygen amounts that can go into the bottles. And we are using a skin that is around the skin that you can see outside, that is really the elastic recovery properties of the wines, of the closures, allowing the closure to perfectly seal the bottle, applying against the bottleneck. So what we want to do is to avoid as much as possible the leakage that can occur between the bottleneck and the side of the closures, forcing all the exchange to go through the oxygen filter. So if we can manage to do it, then we can really control that, because through our production, we can make different sorts of filters. Okay, so that's a very basic foundation of what we are and why we are so much interested in oxygen management. We introduced our first closure in 1909. That was in the US, by the way, and at that time it was called Nomacorc. You know, that was one single closure. It was the name of the company was the name of the closure. Since then, it was renamed Classic, and you see that from 2004 and onwards, we introduced almost one new closure on the market every year. Okay, so that's interesting. The only year that they haven't introduced anything in the company is the year that I joined the company. So I don't know if there is any consequence there, but that's an observation. Okay, and all the closures have something in common, is that they deliver oxygen to the wine bottles, but at different levels. Okay, so we have introduced in 2011 the Select series. So here you have one closure, but in fact we are talking about 4 different closures with 4 different oxygen ingress properties. And the evolution of it is the Select series bio. So just to explain you the Select series concept, this is something that was made and designed based on the research that we performed throughout the world with different partners. And we really took some enological information to try to propose our product development team a range of oxygen ingress that we wanted the closures to deliver to the bottle. So this is something that we wanted to have. So you have here the select 700, 500, 300, and 100. Okay, so that's the name of the 4 closures of the series. And you see what they deliver after 3 months. So you see a difference here. You see difference after 6 months, after 1 year, and then after the first year. Every year you are going to deliver that amount. So you see that there is one closure that is interesting, is the one here, the Select 100, that starts very lower compared to the others, but then will catch up and will behave like a Select 300 almost. So this closure is really unique, is that we have done a lot of work, and at that time, this is when Maurizio was working at the AWRI in Australia. We did a lot of trials with closures that were inerted. So we replaced the air that is, generally speaking, entrapped in the cylinder, and we replaced that with inert gas, and we look at the influence of avoiding this first gas going into the bottle, and we discovered at that time that was really making important differences in wine evolution. So this is what we have developed with the concept of the Select 100. So this is really the first and the only closure that is outgassing treated today in the wine industry. So the Select Bio is an evolution of the Select series that is in fact the sustainable solution with the same oxygen management properties. Okay, so it comes with a zero carbon footprint, is made of renewable plant-based biopolymers and made with renewable energy. So it's not the objective today to talk too much about disclosure, but if you are interested about that, you have some probably on your tables already, you have them in the cigar-like box. So you have a lot of information if you want, but I just wanted to present that this is really the newest evolution of our closure portfolio. So, and it's 100% recyclable, like the other closures of Nomacorc are. So something else that is very important about our company is that we have decided to have an Enology team on board. And that's quite rare in the industry to have really a specialist of wine science in their I would say, team on their payroll. So I'm there, Maurizio is here, we have Edina. She's our product manager. You will see what kind of product we are developing. I'm not talking closures here. Stéphane is our sensory specialist. Jean-Baptiste is developing a lot of different applications. And Magali is our technical writer, trying to put this information together so that we can really share with the industry. So when we started in 2007 to embark in this oxygen management story, we had no resources in-house, so we had to work with people outside. So we started with 3-4 different institutes around the world, but at the end of the day, we managed to have 14 different partners around the world who were working with us, trying to develop this new knowledge about oxygen and wine evolution in time, especially focusing at bottling, but also the role of the closures. And you know, when you have to deal with the evolution of wine in a bottle, you have to understand also what was done before during the winemaking. So we really generated a lot of new knowledge, and this is why now we think that we can propose some solutions. Okay, in time, we developed our own internal team, like I presented before. And so we have a lab. We are located in southern part of France. This lab is fully equipped with regular enological analysis, of course. We have a GCMS facility. We have a sensory panel that is a train panel. We can do experimental winemaking with a small size. So when we want to check some aspects, we can do that. We have a technological hall. And something quite important as well, we have thermostated storage rooms so that we can really store all our trials at the right temperature so we can really monitor what's going on in time over the years. Okay? So our main objective is to understand wine evolution in a bottle. And it's very important for us to look at two aspects, is how much oxygen is going to be delivered to the wine and how this amount of oxygen will impact wine evolution. But at the same time, we want to focus and understand better the importance of consistency. We believe in consistency. We want the wine, all the bottles to develop the same way. When you buy the wines many times from the same producer, from the same label. You want to enjoy the wine always the same way. Okay, so the influence of oxygen on this, and we are going to cover different aspects of this during the different talks today. First one is the oxygen going in a bottle and the influence that it has on the SO2 drop, the SO2 consumption in the wine. So this is what Andrew Waterhouse will cover mainly. We have also an influence of oxygen on the aromatic profile. Okay, we know that some molecules, if you take into consideration the sulfur compounds like the thiol compounds, we know that if they are exposed to oxygen, they are going to decrease in time, while some others, like aldehydes, you need to have this oxygen going in the bottles to have them building up in the bottle, in the wine. So you need to have oxygen managing the different molecules of families of molecules that are present in wine. There is also an impact of oxygen on color. I think it's quite obvious. So probably not so much important when you have a dark red color, because it's quite difficult to see the impact of little differences in oxygen on wine color evolution. But when you are talking about lighter red colors, the rosé wines, or even the white wines, then there is a huge impact on the color development. And last but not least, we are having an influence of oxygen on the polyphenolic content evolution, and that is linked to the mouthfeel. So you can think about astringency, bitterness, this kind of evolution that, okay, for sure it's known in a winery that you want to play with oxygen during wine aging to have a better, or taming your tannins and stuff like this, but you can keep going the same way. And the same thing when you are in a bottle, if you start, or if you keep adding oxygen in the bottle through the closure. So all this will make different wines, okay? And so we wanted to better understand what are the mechanism behind that. Can we predict that? Can we manage that? Can we keep all the bottles at the same level? Can we be consistent? So these are all the challenges that we need to address through research and through observation by a lot of different trials and to better manage all that. So this is what we are going to cover today. I want also to explain to you that, okay, we are a closure company, but through this process of developing research partnerships, developing new trials and stuff like this, we needed tools, because we realized that sometimes we do an isolated trial and we have one single result and we say, oh, that's great. Well, how can we really extrapolate this result to another place? So we understood very rapidly that we needed to have a lot of analysis performed. And for that reason, we needed to have tools that would allow us to measure as often as we want, so that we can start building databases, so that we can have results and we can really make some models, some observations that are not true just for one single wine, but something that we can apply to an industry. So the first challenge for us was to measure oxygen in a way that is easy, so you don't even guess that, should I measure or not? It's so boring. No, you need to measure. You need to have a lot. So first thing that we needed to develop was an oxygen analyzer that we call NomaSense O2. And this is based on the Luminescence technology. So the beauty of this is that it's a non-invasive technology. So you have sensors that are separated from the device, from the measuring device. So you have dots that can be glued inside the bottle if you want to measure in a bottle, for instance. Okay, so you glue the dots before you fill a bottle with wine. And then you are going to use an optical fiber, and you measure through the glass what's inside the bottle. So you don't open. There is no interferences with the oxygen that is outside. Okay, so that's very convenient. The principle is very simple. You are emitting a red light, thanks to the device, okay, that you are applying to the sensor. The sensor will get into an excited state for the electrons, okay? And depending on the amount of oxygen that you're going to have around the sensor, it's going to takes the red light more or less time to get back to the device. So we are just measuring a delay between a blue light that is emitted and a red light that is emitted back to the device through the same optical fiber. So very, very simple, but all the intellectual property resides in the fact that the sensor has to be 100% specific to oxygen. Okay, so we found this technology in another industry. That was not in the wine industry, that was in the medical industry, that was in the beer industry. And so what we do is that we are just opening our eyes, searching a little bit around in other industries, people having some problems like we can have in wine. So we take the technology and we develop the application to make it possible in the wine. Okay? And we have published all the validation of that, and it's now recognized, I would say, without being too proud of ourselves, it's quite recognized as the reference method now to measure oxygen in the wine industry. The beauty of it is that you can really measure oxygen everywhere in the process. And you have different tools that allow you to measure oxygen whenever you want. So you can measure in a tank, or that's a tank that could be a barrel. So you have a big container. You can use a dipping probe. So here, instead of having a sensor that is glued inside, you have the sensor that is glued in the dipping probe directly. So you just dip inside, and you can measure if you want to measure here at a different level in the tank, you can measure it. Okay? You start with it, so you have the starting point, and then, okay, you need to move the wine. Every time you move the wine, either through a pump, a filter, cold stabilization, whatever you want to do, you can map this process and make sure of and really perform measurements so you know the exact pickup for each step that you are putting in place in your winery. So you just put a side glass before and after with a dot inside, and you just go there, you can measure here, you can measure there. We have even developed tools here to replace the side glass, and we are just putting the probes in it. You don't have to take care of that, and it's just measuring over time. So you can really map all your process like this. Is this filter better than another? Is my microfiltration really zero pickup? Who knows if you don't measure? So you need to be very careful not to trust some big principle, because sometimes when you start measuring, you realize that, it's a bit different from what I thought. So you want to know what to do? You can measure, easy to do. Okay, and then the main application for us was to really focus around oxygen going in a bottle. So the bottling process, and this is what Hand will cover later on, and also the influence of oxygen through the closure on wine evolution. With the same device, we could measure everything. So that was the beauty, is that all the academic partners that I showed you before, they were using the same technology and they were measuring every time. So all the information came with the same technology. So we can really compare apples to apples. Okay? So different tools that we can use, the dipping probe, like I said, the dots that can be glued inside a bottle, but they can be also glued in a bagging box spout. So if you want to measure oxygen in your bagging box, you can use that. You can first turn it, so you have the bubble, the headspace. Okay, so you can measure this in the headspace, and then you just use your tap to have the wine going through the tap, and you measure while you are pouring the wine. So you can measure oxygen in the bagging box. Piercing system, in the case that you don't find bottles that are clear glass. Sometimes you are using some customized bottles, and it's quite tricky to find the equivalent clear glass. So we have developed something where you can really screw on the bottleneck here. You use a piercing system, very simple. You can even go through a screw cap if you want. It's very demultiply force here, easy to do. And you have a syringe here, and you put one of the sensor in the syringe. You put the headspace in the equilibrium with the syringe, and you can measure in there. You will see the explanation a little bit further with Hand later on. Okay, so that was the first thing, measuring the source of the problem, okay, or the source of the wine evolution, oxygen itself. But we also talked about the fact that the wine is evolving. So we wanted to have tools to monitor wine evolution in an easy way. So one thing that is, and I'm going to present two of the tools that we have developed today because we don't have so much time, but it will give you a feel for what we are doing, and we are developing others. So another thing is to measure color in an objective way. What we realized is that sometimes we are doing experiments and looking at a 420 nanometer, 520, 620, okay, sometimes helps. Sometimes it's not so conclusive. And we believe that we need to have a clear, objective assessment of the color. If you think about the other industries, they are measuring color. In the paint industry, in the car industry, when you buy your Ferrari, you want the red Ferrari. You don't want a sort of fake red Ferrari, right? So you need to have this very same color. And a color is defined by coordinates. We could use the same system here that is normally used to measure the color of this wall, of this curtain, etc. We modify the system so that we can use this methodology to measure the color of a wine. So we developed a small cuvette behind, and we are measuring color. The beauty of it is that because it's a reflectance system, you don't have to filter your sample, you don't have to centrifuge or whatsoever. You can just take a sample in your winery that can be a must, a wine in fermentation or things like this. You put it in a cuvette, and you can measure right away. And you are going to be given with the LAB coordinates, which define one single color. So if you want to do the wine of this color you did last year, you want to redo it this year, you can really compare and monitor your color based on these coordinates. So you will see some of the illustration of how we use that. And the last system that we developed is sort of polyphenol analyzer. Maurizio will cover that later on, okay? So I'm not going to go too much into details here, but you have to realize that when you think about measuring polyphenols in the wine industry, we can't go with HPLC, mass spectrometer, and blah, blah, blah. We need to think about routine. So how can we do that? So this is what we found in the health industry. You know that some people are using these kind of strips where they do some blood test to measure their sugar content when they are sick with diabetes. And so we took this technology, and in fact, we could develop disposable small electrodes. So here in the small strip, you have the working electrode, the reference electrode, and the counter electrode that are printed at the same time on a very small thing. And you can measure that. You can use that to measure the polyphenolic content of the wine, of grapes, homogenate, etc. So Maurizio will explain that later, okay? But just to explain to you that the Enology team of Nomacorc is working not only on qualifying the performance of our closures, but also developing tools that we can give to the winemakers to have some sort of decision-making tools. And this is part of our job, I would say, to integrate all that together. Okay? So today, like I said before, we are going to have, as a second speaker, Hen Letayev. She will be talking about monitoring oxygen at bottling, during the bottling process. Andrew Waterhouse will cover oxidation mechanism, and Maurizio will end up with some ideas about how could we predict the oxidability of wines. Okay, before going to the bottle, what could we know about this wine? Is it a sensitive wine? Is it a wine that is really supposed to be oxidized very rapidly? How can we do that? Okay, with some simple tests.